Hello, today we are finishing Chapter 2 by covering Lesson 2.8, Proving Angle Relationships. You guys will be able to write proofs involving complementary and supplementary angles, as well as write proofs involving congruent and right angles. Now, we're not going to do just proving today like we did the other day. We'll do some solving of things and learning of some new postulates and theorems as well. So our first new postulate is the protractor postulate. This is very similar to our previous lesson's ruler postulate, except this time we are given any angle. The measure can be put into one-to-one correspondence with real numbers between 0 and 180. So we have ray BA placed along the protractor is 0 degrees. Then the measure of our angle ABC corresponds to a positive real number, in this case about 146 degrees. So I won't use that one too much, but it's just stating that we can use a protractor to find degree measures if we are given an angle that is to scale. And the angle addition postulate is similar to our segment addition postulate. We're going to use this one a bunch, so I would make sure to highlight it. Keep that in your mind, okay? So this states D is in the interior, point D is in the interior of our angle. If and only if the measure of ABD plus DBC equals the whole thing ABC. So we learned this earlier in the year. Hopefully you recall that. The part angle plus the other part angle has to equal the whole angle. So let's do some. We are going to find the measure of angle 1 if the measure of angle 2 is 58 and the angle JKL equals 162 degrees. Then we're going to name the theorem or postulate that justifies our answer. So I know that the measure of angle 1 plus the measure of angle 2 must equal 162 degrees, right? That is our angle addition postulate. So now I can substitute in 58 for the measure of angle 2. The measure of angle 1 plus 58 equals 162. And then solve for the measure of angle 1. So I get 104 is the measure of angle 1. And then I use the angle addition postulate as my reason, okay? Make sure, don't just write the word addition. We have segment addition postulate. We have addition of congruence. Okay, don't just use addition. We have to state exactly which sort of addition we're using. Okay, so now another one. The diagram shows one square of a particular quilt pattern. If BAC is equal to DAE, and DAE is 20, we also know BAC is 20. And we know BAE is a right angle, which means it's 90 degrees. We're finding the measure of CAD. So we can take, using angle addition postulate again, 20, plus the measure of the missing angle, plus 20, has to equal 90. And we can go ahead and solve. So we have the measure of angle CAD is equal to 50 degrees. We didn't have to write a reason, but it would just be angle addition postulate once again. Okay, we have two other theorems here. We also learned these early in the year. They're just all in one slide for you. We have the supplement theorem, so if two angles form a linear pair, then they are supplementary. This just means you can add and equal them to 180. We've been doing that lots. We have the complement theorem. If the non-common sides of two adjacent angles form a right angle, So basically, if two angles form a right angle, then their angles are complementary, so you can add and equal them to 90. Also done that one a bunch too. As I said before, we'd see reflexive, symmetric, and transitive a lot. Here we are with reflexive property of congruence for angles, so we just know that angle 1 is congruent to itself. We know for symmetric that 1 is congruent to 2. That means 2 is also congruent to 1. And for transitive property, if 1 is congruent to 2 and 2 is congruent to 3, then we know that 1 and 3 are also congruent. All right. A few others here. We have the congruent supplements theorem. This states angles supplementary to the same angle or to congruent angles are congruent. So we have here angle 1 and angle 2 added equal 180. We also know angle 2 plus angle 3 equals 180. So because they both equal 180 and both include 2, that means angle 3 and angle 1 must be the same degree. They are congruent. Similarly with congruent complements theorem, if 4 plus 5 equals 90 and 5 plus 6 equals 90, then 4 and 6 must be the same degree. They must be congruent. So we have a quick proof here. We are going to just go ahead and start by writing out our given. I'm going to shorten it to angle 1 and angle 2 are complementary or comp. And angle 2 and angle 3 are complementary. You should never miss these, because they are your given statement here. Okay? And then I'm going to scroll up here. Because it's the congruent complements theorem, we're going to use this picture here. So this is a good picture, except we have angle 1, 2, and 3 instead of 4, 5, and 6. So we need to get that angle 1 and angle 3 are congruent beyond a shadow of a doubt based on a proof. So our second step, we can take angle 1 plus the measure of angle 2 equals 90, and the measure of angle 2 plus the measure of angle 3 equals 90. Now this is because they are complementary. So we can use the complement theorem because we are adding these. Now, I suppose it would be better if we just use the definition of complementary angles, because this one, they don't have to be adjacent to each other. So we'll actually use the definition of complementary angles just so we're make sure that's actually true based on the definitions given by our postulates and theorems as our reason for step 2. Okay? So I know because they are complementary, they must add and equal 90. Now because both of these things equal 90, we can plug all of this in for 90. 90 is 90, so we can just plug it in. 90 equals a measure of 2 plus measure of 3. 90 also equals measure of 1 plus measure of 2. So we can set them equal to each other. By substitution, which you may shorten to subs if you like. Make sure it's subs, not just SUB, because SUB could be subtraction. Go ahead, you can rewrite this, because next you'll notice that we can actually use the subtraction property of equality. And then we always have a solving step that follows an operation step. So we'll have substitution, where we solve these down. So we'll have ME, measure of angle 1 equals the measure of angle 3. That's substitution, property of equality. And then we don't want to get to equals, we want to get to specifically congruent, so we can use our definition of congruent angles to prove that these two angles are indeed congruent. All right. Now we have another proof. That's our vertical angles theorem. We've already covered this. If two angles are vertical, they are congruent. We need to prove it. So we have angle 1 is congruent to 3. Angle 2 is congruent to 4. We are going to prove this. If you are not given an explicit given statement and prove statement, you can figure out what these are based on your if-then statement. Your if is your given. Then your conclusion is your proof. So I'm going to make this a little narrower based on this picture and say that my given is angle 1 and angle 3 are vertical. They're vertical angles. Because we have two angles that are vertical angles is our given. And then we need to try to prove that those two angles are congruent. So I'm going to follow a similar pattern to our first example, but this time I'm going to use 180. So I have measure of angle 1 plus the measure of angle 2 equals 180. And I'm going to use the measure of angle 2 plus the measure of angle 3 equals 180. Now I see that 1 plus 2 has to equal 180 and 2 plus 3 has to equal 180. So this would be the definition of a linear pair because they form that straight line. Step 3, like we did on the last one, we noticed that these both equal 180, so we can substitute this in. So we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And that's by substitution. And now we're basically back where we were for the last problem. We can do a subtraction here for step 4. Oops, let me copy that down. Trying to get ahead of myself. So that's step 4, subtraction, property of equality. Step 5 then, we always have our solving step, so it's substitution. And then we finish it out by stating that these are congruent because that's what we are trying to get to, that those two angles are congruent. So we have angle 1 is congruent to angle 3. That's the definition of congruent angles. And we're done. Actually, I think I forgot my box on the last one. We finished on both of these. We have proven what we set out to prove. Hopefully those weren't too bad. The mini proofs that you have for homework are actually no more than 5 steps. That's the least possible for one of them. The other couple are 3 or 4 steps. That's the least possible amount of steps you could take to solve. Alright, these next few slides, we are going to solve for x and then state the theorem that justifies your answer. So, to solve for x, I notice this is 90, which means I'm just going to add and equal these to 90. We've been doing these since the beginning of the school year, where we decide if we add and equal or if we set them equal to each other. Oops, not 180. It's 90. And then we go ahead and solve. So our x value is going to be 9. Don't forget we have to justify. I'm going to justify using the complement theorem. Because this is two angles that add and equal 90 degrees. For this problem, we are going to solve for x, so we have to figure out what we need to add and equal or equal them to each other. I notice they are on a line, so we are going to add and equal them to 180. And then we go ahead and solve. We solve and x will equal 16. Now this is similar to the last one, although this time we add and equal to 180, so it is the supplement theorem. That we used. And now we do this one. I notice that these guys are vertical angles, so I know I'm going to use the vertical angles theorem and equal them to each other. So I have 2x plus 1 equals 49. I solve and x equals 24. Okay, so that's what your book work's going to be similar to. You're going to do stuff like that. Find missing angles. On some of them, it's going to ask or tell you the first few to find the angles of missing. It'll give you one of the angles. That's not just your answer. You're going to find angle 1 and 3 also, and then state how you found those. Then you'll find 2 and 3 or something like that based on what you're given, okay? So you're going to find angles 1, 2, and 3 for the first two problems, and then 4 and 5 for the second two. Use what you're given only per problem, okay? Now for our theorems, we have the right angle theorem. There's a bunch of them. 2.9, 10, and 11 all go off of this first diagram. These are pretty self-explanatory. If you have perpendicular lines, they intersect to form 4 right angles. We knew that. We know that all right angles are congruent. They're all 90 degrees. That means they're congruent. We know perpendicular lines form congruent adjacent angles. So we know 2 and 4 are congruent. 4 and 3 are congruent. 3 and 1 are. 1 and 2 are. We know that the adjacent angles are congruent because they're all 90. We also know in 2.12, if two angles are congruent and supplementary, then each angle is a right angle. So if they are congruent, they have the same degree, and they are supplementary, that means they must be 90 degrees apiece. And if two congruent angles form a linear pair, then they are right angles. So if these angles are congruent, they form a linear pair, they must be 90 degrees or right angles. And that is all. Have a great afternoon.